Hello, everyone, and welcome to another topic in chemistry. This is the first day of our what is Unit 4 for Pre-AP Chem, and the focus is something called dimensional analysis, which I sometimes refer to as chemistry math. So let's go ahead and get ready. You could pause the video quick if you don't have a calculator close by. You will definitely want one for some of the stuff we're doing today, so go grab that. And then when you're ready, set up your focus notes. The topic is dimensional analysis. Fill in whatever date you're taking these notes. And our essential question today that we're going to answer that guides our learning is, how do I use dimensional analysis to solve conversion problems? So today is going to look a lot like kind of random math sorts of questions, but we're building it to eventually have it become chemistry math. So you'll hear me say this a couple times, but right now, just trust that I'm teaching you a new problem solving technique. It's not the only way to solve problems. It's not always the best way, but you need to learn a new skill for problems when it is the best way to answer the math part or the conversion part of it. All right. So let me introduce this idea. You don't have to take notes on this slide. Let me just kind of introduce what I'm getting at. So imagine that I came to you on our Zoom and I was like, hey, after school today or when I'm done teaching, I'm supposed to go drop off some meeting materials at a colleague's house. So I've got, of course, my app on my phone that should help me get to my colleague's house. But that app is only going to work if what? Like, I don't just hit that app and it suddenly tells me how to get to this colleague's house, right? What do I got to know? Think about it. Well, yeah, the phone has to recognize where I am, and then I have to be able to type in an address or where I'm going, some common, whether it's a common landmark or an intersection or an exact address, I have to be able to tell that, and then I have to drive there. Well, chemistry math, this new thing called dimensional analysis, works the same way. It's a really good problem-solving process when you have kind of like a big unknown. So like if I've never been to this colleague's house before, I have no idea where they are, this app is super useful. But if I'm going to a place that's familiar, probably I can just get there on my own. And sometimes the map directions or the app, like it's totally superfluous. It doesn't even help me, right? Well, chemistry math, again, I'm going to have you let go of that. Like, wait, I could solve these problems some other way. Well, just like that app, the app only works in certain situations. And that's what I'm training you for. How do we use chemistry math in situations where it is the best option? That's what we're getting at. Okay, so if you're going to take notes, here's where I would start. We're learning something called a problem-solving process called dimensional analysis, which I will almost always abbreviate DA. The definition of DA is use the dimensions, which are the units of a number, like the measurement pieces, to convert that number to a different number and its unit. So I could ask a question, how many miles is a 5K race? Well, you'd have to know that 5K really stands for 5 kilometers, but maybe this is something you hear people talking all about and you're like, but I don't really know how long kilometers are. So you've always wondered, how many miles is that? That would be a problem that we could use dimensional analysis to solve. Now, again, you might just know this answer, or you could solve it some other way. But the point is that dimensional analysis will work to solve this, and we're going to learn how to do it so we can use it when it's needed. In order to do dimensional analysis, you need to know lots of different conversion factors, which is a unit and a number equal to another unit and number. So like, for example, 52 weeks in or equals 1 year. You would never believe me if I said 52 equals 1. That doesn't make any sense. Or weeks equals year. That also doesn't make any sense. But if I put this unit and this unit and this number and this unit and this number, I can say they're equal to each other, just like I could say 3 equals 3. 52 weeks equals 1 year. Those measurements are interchangeable because they have different dimensions. They're thinking in different dimensions. That's the idea. So that is what DA is all about. Answering questions between different units or like these different units using conversion factors to get there. Go ahead and do a level 1 question so far. Something straightforward, maybe a definition or complete the sentence, those kinds of things, but something comes right from your notes. Go ahead, pause the video, start it up when you're ready to come back. All right. So again, if you're taking notes for this slide, just write down the stuff in pink. So that map app example or analogy that I made, DA works the same way. You have to know where you're starting. So like in the map app, like the phone or the satellite that connects to the phone tells the app where you're starting. For DA, we call that the given. So you will hear me say this a lot. What's your given? Find your given. Write down your given. Literally, it's called that because it's what's given in the problem, your starting number. Then you have to know where you're going. So in the map app, you had to type in some address, right? Or an intersection or a landmark. For DA, that will be figuring out, well, what's the problem asking you to convert into? Like, what are you trying to solve for? Like, what's the subject of the question? Then you how to get there. So for the map app, that would be like the step-by-step driving directions that it gives you. But for DA, those are your conversion factors. So you're going to set up different conversions so that old units cancel. So we're going to be setting up ratios. So it's like a top and bottom. They're going to divide away. And then you'll be left with some new unit. And then, of course, you have to get there. So for the map app, that would be like following the directions and driving or walking there. For DA, this is where you would do the math. The math is really just multiplying and dividing. That part's not hard. It's the setup that takes some getting used to. And then for the solving, you just have to remember that when you set up ratios, you multiply numbers on top of a ratio, you divide numbers on the bottom of a ratio. So that'll take maybe a little bit of getting used to. But what we're really doing is again, we're learning a new skill. So when you're doing these problems, don't try to do them a different way, because it's not about just the answer. It's about, can you do this new skill of setting up dimensional analysis problems? So what is your given? That's what you write down first. And then figure out where you're trying to get to. What's the problem asking for? Set up the conversions that connect your given to what the problem's asking for, and then you'll solve it. Those are the steps of DA. Why don't you go ahead and do a level 2 question, maybe a summary. Summarize the steps of DA. That would be a great level 2 question. Or sketch a picture that represents these steps of DA. That would be cute too. All right, pause the video, come back when you're ready. All right, so we have to think about ratios in order to understand DA. So let me get you started to think about ratio. When I show you this 4/2, what does that slash mean in terms of math functions? What does that slash mean to do? Yeah, it means to divide. Okay, good. So if I say 3 divided by 3 equals 1, would you agree with this? Yeah, I think you would, because anytime you have the same thing on the top and the bottom and you divide, it's kind of like they cancel, so it divides out to 1. What if I say 5 divided by 5 times 3 divided by 3, that equals 1? Well, wait a second, how could all these numbers equal 1? Well, because you recognize, 5 divided by 5, that's really just cancels, that's 1, times, 3 divided by 3, that kind of cancels, so that's 1. So really it's like 1 times 1 equals 1. Okay, so this is reviewing that you can multiply and divide, or you could have done 15 times, or 5 times 3 is 15, divided by 5 times 3, right? Because these are both on the top and these are both on the bottom. So really it's 15 over 15. Well, that also equals what? That would work, okay? What about if I said this? 5 times 3 over 3 equals 5. Okay, well, yeah, that makes sense, because this 5 is all by itself, times 3 over 3. The 3's cancel, so that's like a 1. 5 times 1 equals 5. Okay, what if I say this? 1 equals 100. Oh, man, you were so used to agreeing with me, you almost said yes to this, didn't you? No, it's not true. But what if I say this? 1m for meter equals 100 centimeters. This is true. So again, when you put the dimensions or the unit of measurement with a number, you can say these two things are equal to each other. But without labels, you can never say 1 equals 100. It's not true. It doesn't make sense. It's weird magic. And then so now let's start to put all that together. 5 meters times 100 centimeters divided by 1 meter equals 500 centimeters only. Okay, let's see if that makes sense. Well, 5 times 100, there's the 500, and then divided by 1. So that's 500. That makes sense. But then you've got meters times centimeters divided by meters. Well, we talked about here, if you have the same thing on the top and the bottom, it's like they cancel out to 1. So meters divided by meters goes away, and then centimeters doesn't cancel. Nothing else multiplies, so it's just centimeters. 500 centimeters. That is a one-line version of a dimensional analysis problem. We started with 5 meters. We found a conversion between meters and centimeters. We did our math. We canceled stuff out. 500 centimeters was the final answer. So that's the idea of what we're going to start doing. Go ahead and do a level 3 question. You could always use defend or argue in favor of using DA as a problem-solving process, or any other type of predict a time when DA will be useful. That would be good. All right. And then I'm going to ask you that one more time, that idea of letting it go. It's so easy to be like, I'm really good at math. I want to do these problems my own way. But remember, you're learning a new skill. It's not about the math. It's not even just about getting the answer. In fact, in some of the problems you're going to start today, I give you the answer. You're learning a new skill for problem solving, and that problem solving skill is called dimensional analysis. And the other thing is, trust me, I'm asking you, I hope I've built up your trust over this trimester, but trust me that I'm preparing you for something when DA DA will be the best option. It isn't always the best option, especially for those of you that are really good at algebra and manipulating equations and math in your head and stuff like that. But eventually, I'm going to show you problems where DA is the best option. It's still never the only option, but I'm trusting you to just let it go that I could do this some other way and instead be like, I want to learn a new skill. And that new skill happens to be called DA. Okay, so what I want you to do quick right now is you have an assignment in today's Schoology folder called DA Intro Practice. Will you pause the video and go open that real quick? Go open that thing called DA Intro Practice and then come back to the video when you're ready. So what you're going to do is I give you what I call math puzzles on this intro assignment. So what I've done is I've given you some blanks, I've given you some pieces, and I've given you the final answer. So what you have to do is you have to fill in the different blanks. It doesn't look exactly like this, but just imagine you have to fill in the different blanks to equal the answer that I give you, showing you how to set up DA problems. And remember, you think of it this way. Where am I starting? That goes in the first blank. Like what's given in the problem you're given is the first thing you're starting with. That goes in the first blank. Where am I going? That should match the answer. So that should be in your last blank, should be whatever units we're looking for. Set up your conversion, solve the problem, label, and oh, look at this. Sig figs come back. We learned about that in December. You might need to go back and review that, but we'll review it a little bit now too. So after I do an example with you and show you how to set up the DA problems, you're going to go to the second page of this assignment and you're going to set up the other problems. There's just a few more, 8 if I remember correctly, on the second page to practice doing DA when you have to set it up from scratch. And just so you know, on this worksheet, I believe it's the third page of this handout, it's got a whole bunch of conversions. There's a lot of conversions I don't expect you to just have memorized. So you can look at that conversion list on that third page of this handout. Let's go ahead and do some together. Oh, another thing is you've got a fancy button on your calculator that shows you scientific notation. We talked about it again way back in December, but just remember to use that scientific notation button instead of trying to do like the caret key, power of 10, parentheses, and all that extra stuff. I'll talk more about that next time, but just remember that you've got that fancy button on your calculator. Okay, so now on that DA intro practice, that handout that you just opened, we're going to do one of them together. So let us do one together. It says, how many centimeters are in 18.5 feet? Here's the things that we know. So here's your puzzle pieces. I know 1 inches equals 2.54 centimeters. I know 12 inches equals 1 foot. And this is pretty much just a definition. So this doesn't really count for sig figs because it's an exact just definition. This counts for sig figs because someone had to figure this out. They had to write out an inch and then they had to measure how many centimeters would that equal. So this is specific 1, 2, 3 sig figs. This is a definition. These two are definitions. So they're like considered exact, indefinite number of sig figs. So then we're going to fill in the blanks with the given information to equal the answer shown. So again, think of this like a math puzzle. Here are your pieces to fill in. Here's the final picture. So let's go through the steps. Where am I starting? Go back to the problem. How many centimeters are in 18.5 feet? This is your given. It goes in the first blank. So fill that in. Do this problem with me. If you haven't yet opened this document, go stop the video and go open this problem, this assignment, DA intro practice. We're doing number 1 together so that I can kind of start to show you how this works. So the given is 18.5 feet. The second part is what's the problem asking for? How many centimeters? So I want centimeters to be the last thing in my brackets, the thing that does not cancel. So we're trying to make our words cancel out and get to a new word. I don't want to be at feet. I want to be at centimeters because that's what answer this problem. And eventually we're going to put chemistry stuff into this, grams and moles and formula units and all these other things that we don't even all know about yet. But for now, we're just practicing DA. So feet to centimeters. Look at the puzzle pieces you have. I know that 1 foot equals 12 inches. I could use this conversion to cancel feet and get to inches. So then I want feet to cancel. So we know in math, if you have the same thing on the top and the bottom, it cancels. So I'm going to put 1 foot on the bottom, and that's equal to 12 inches. Because again, I can't just put 1 and 12. That doesn't make any sense. But it does make sense if I say 1 foot equals 12 inches. And it doesn't matter which one's on the top or bottom because they're equal to each other. But I want feet on the bottom in this case because I want feet to cancel. When the same thing is on the top and the bottom, they divide out to 1. So it cancels. Well, now I'm at inches and the problem wants centimeters. So once again, look at your puzzle pieces. Oh, wait, inches to centimeters. So once again, I can put inches on the bottom, 1 inch, And then I can say it's equal to 2.54 centimeters. Same thing on the top and the bottom. Inches divided by inches goes away. I'm left with centimeters, which is what the problem is asking for. So notice none of the numbers canceled. So now you would do your math like normal. Grab out your calculator. 18.5 times 12 times 2.54 divided by 1 divided by 1. Get your answer on your calculator. Now, yes, of course, you could skip the dividing by ones because that doesn't change your math. Some people still like to do them just to remind yourself, oh yeah, any number on the top I multiply, any number underneath the dividing line, hit divide. So don't try to do multiply two numbers on the bottom. It's divide, divide. The calculator gives you this answer, all right? So hopefully you agree with me. Double check your math if you did not get this answer on your calculator. But then now here's where you have to review sig figs. And if you need a bigger reminder, we learned about sig figs on December 16th in the week 2 Schoology folder. All right. We said these two numbers are definitions. They don't count for sig figs. But this one has 1, 2, 3. This one has 1, 2, 3. So I can keep 1, 2, 3 sig figs. I look at this number for rounding, which it does. So this rounds up to a 4. That's where 564 centimeters came from. And again, you got to let go of that idea. Like these numbers, I was never this specific. I couldn't be this specific in my math because my measurements were not that specific. So I can't have 5 sig figs suddenly when my measurements only had 3. So 564 centimeters is the science answer. All right. Good job. No, actually, awesome job. Excellent. All right. I'm hoping this is starting to make sense. There's a couple more practice problems, kind of like those puzzles set up for you on this page. And then the second page, you're still going to set them up like this, but you have to start from scratch. So just trying to give you some training wheels to get started. The more practice you see, hopefully this will start to make sense in terms of puzzle pieces. Of course, if you still have questions, just make sure you're asking. That brings us to the end of the first day of this new unit on chemistry math. Finish your Costa questions, write your summary for today, and then you're going to work on that DA intro practice. We did problem 1. There's a couple more training problems. And then the middle page, the second page, is 8 more examples where you just kind of start from scratch, but still do the same steps. And then the third page is just conversions. There's no work to do on the third page of this practice assignment. You could also start the unit practice problems. So UPPs, they're in the week 7 folder. The answers are given, remember, so it's a chance for you to check your work and get immediate feedback. So you could just do the first like dozen of those problems, 1 through 12, or just do a couple of them. You don't have to do all of them. They're for your practice. But if you need it, it's a good resource. All right. And then I just want to give a shout out reminder. If you are watching this video on the day it was assigned, your types of reactions lab report is due on Friday of this week. So don't forget about that. Use office hours if you have questions on today's notes, on today's assignment, on past assignments, on this lab, or if you just need to check in. Just remember, I'm here to support you. Thanks so much for listening. We'll talk to you later. Another day for DA. Bye.